Hello, this is a video where we're going to look at graphs that use the letter E, Euler's constant. So it might be a graph, an exponential graph. It might be an exponential graph that looks like this, y is equal to e to the power x, or it might be a log graph. And so it might be the graph y is equal to log to the base e of x. Now, because mathematicians use this base e a lot of the time, they have another shorthand which they use for log to the base e. They'll refer to them as being the natural logs, and they will always write this as ln, saying it's a natural log of x. And you need to understand that if you see y is equal to ln of x, then you're working with the base of e. Now, why e is such an important number is that it appears often in naturally occurring growth patterns, and so we tend to use it quite a lot. So the letter E is this number that Euler is attributed with, finding and working with. If we go and look at the letter E, what the actual number is on the calculator, we have it there. It's just the number 2.718281. I can't put too many things on there, but no. Looks something like that, and it keeps on going. Now, it can be used in an exponential situation. It can also be used in a log situation. So we're going to have a look at those two and see what they look like. So if we go to the graphing package and pull it over, I just need to clear all the stuff that we got here and just delete that. And there we've got a nice screen. So the first of the graphs that we'll look at is y equals e raised to the power x. And we can see here that it is just an exponential graph as we'd expect. If you remember that e is just this number 2.718, that is basically the base that we're working with. So that's a simple exponential graph, an e graph. If we go and look at the log graph of this, we're going to get y is equal to ln of x, and you'll see that it too is a log graph, just as we'd expect it to be. And if we go and put in the line y equals x, the reflection line, the mirror line, we'll see that these two graphs reflect each other in this line. So I can put this graph over onto that one, and we'll see that they appear to lie one on top of each other. So the natural log graph, the ln graph, looks like this. The brown graph over here, that's the exponential graph. The green graph is the natural log of x, and that looks like any log graph would. And that's not too surprising because we're basically dealing with log to the base of 2.718 . So those are the graphs of these two functions. So I've just taken a copy of this and let's put it down over here. We can see there are two graphs. Let's just move this over slightly. Okay. This one is the graph y is equal to e to the x. This is the graph y is equal to the natural log of x. Oopsie, something's happened. Y is equal to the natural log of x. Let's just delete that line that went out there. Natural log of x. Okay. Now, the reason that I bring up these two graphs, along with the graphs that we did earlier, the log graphs that we had over here, is that at a later stage in this course, you're going to use your calculator to model curves, and the calculator will give you the option of using a base that's either a number, like 2 or 2.5 or 3.7, or it'll give you the option of modeling it where the base is going to be the letter E. Okay, so this value E that we have over here. And so I bring it up to you for you now so that you can see at a later stage that we can use either our base E for a curve, or we can use a whole number like we've got over here for the base, or it could be a decimal as well. But they are basically going to give us either an exponential curve or a log curve, and we're going to be using that at a later stage. So I hope this helps. Goodbye.